You ever stop and think about how a simple, common element like sulfur gets turned into one of the most powerful, most important chemicals in the entire industrial world? Yeah, it's not just a simple reaction. It's more like a carefully perfected recipe for creating some serious chemical power. And today, we're going to break down exactly how it's done.
So that's the big question, isn't it? How do you even begin to make an asset that's this fundamental to, well, pretty much everything? What's the secret sauce behind its massive production? Let's dive in and really get into the step-by-step process. But hang on, before we get into the how, let's get properly introduced to the star of our show today, sulfuric acid itself. So what makes this stuff so special? Well, one of its key features is that it's a non-volatile acid. All that means is it doesn't like to turn into a gas. It stays put as a liquid, which you can imagine is a super useful property when you're working with it on an industrial scale.
And this acid has been around for a long, long time. The very first methods actually involved distilling this old-school mineral called green vitriol. It's a really fascinating, almost alchemical beginning for a chemical that honestly went on to build the modern world. But today, the method is way more precise.
So let's get right into that modern method. Think of it as this super efficient, three-step recipe that's been tweaked and perfected over the years. This industrial-scale recipe has a name. It's called the contact process. And that name actually gives you a massive clue about how it works. It all comes down to a crucial step where gases make contact with a very special substance that kicks off the most important reaction.
And here's the game plan, the roadmap for the whole thing. It really just boils down to these three main stages. First, burning. Then, a really critical step called catalytic oxidation. And finally, absorption and dilution. Let's tackle them one by one.
All right, step one. It all starts with fire. You take pure, simple sulfur and you just burn it. Burn it in the air with plenty of oxygen. This really straightforward reaction gives us our first key ingredient, a gas called sulfur dioxide, or SO2. Simple enough, right? Now for the real magic trick. That sulfur dioxide gas we just made gets oxidized, which just means we're going to jam another oxygen atom onto it. And that transforms it into something new, sulfur trioxide. This is the absolute heart of the contact process, but it needs a little nudge to happen efficiently. And that little nudge, it comes from something called a catalyst. In this case, it's a compound called vanadium pentoxide. You can think of it like a chemical matchmaker. It just encourages the sulfur dioxide and the oxygen to get together and react way, way faster. But it doesn't actually get used up in the process. It's just there to help things along. And the result of that little nudge is, well, it's incredible. Thanks to that catalyst, this one step achieves a 98% conversion rate. Just think about that for a second. Almost every single molecule of sulfur dioxide gets turned into sulfur trioxide. And that's the kind of insane efficiency that makes this process so dominant, so profitable for the industry.
Okay, so here's a really critical point. You'd think you could just add water to the sulfur trioxide now, right? Wrong. If you did that, it would create this crazy, uncontrollable, dangerous acid fog. So instead, the gas is bubbled through sulfuric acid that's already been made. And this creates a totally new intermediate substance.
And that substance is called oleum. It's basically this super concentrated, fuming version of sulfuric acid that's holding all that extra sulfur trioxide. We are so close to the finish line now.
And here we are, the final touch. That oleum is carefully, very precisely mixed with soft water. This final, controlled reaction is what gives us our product. For every one molecule of oleum, you get 2 molecules of pure, concentrated sulfuric acid. And just like that, our recipe is complete. We've made our super acid.
So now that we've cooked our acid, what's it actually like? Let's take a look at its physical identity and, some of its more surprising personality quirks.
So, on the surface, it's actually pretty unassuming. It's colorless, it's odorless, it's heavier than water, and has a really high boiling point. But, looks can be deceiving. Beneath this simple exterior lies a pretty fascinating secret.
And this brings us to one of its most interesting properties. It's a real paradox, a tale of two conductivities. This is just wild. In its pure, super concentrated form, sulfuric acid is a terrible conductor of electricity. It's practically an insulator. But, and here's the twist, add just a little bit of water, and that dilute acid becomes a good conductor. So the simple act of diluting it completely flips one of its most fundamental properties on its head. So what a journey, right? From a raw element to a finished industrial powerhouse. Let's wrap things up with the final word on what we've just seen.
Okay, quick recap of the whole trip. We started with his non-volatile acid, totally essential for industry. We learned it's made using that crazy efficient 3-step contact process. We burn the sulfur, use a catalyst for a near-perfect reaction, and then absorb the result before that final careful dilution. And, of course, we discovered its coolest party trick, how just a little bit of water completely transforms its ability to conduct electricity.
And that kind of leaves us with one final thought to chew on. We've seen how the fundamental nature of this acid can be completely changed with just a little water. It really makes you wonder, doesn't it? What other simple additions out there are creating equally huge and maybe totally unseen transformations all around us every single day?